Hello everyone. Today we're going to talk about Warshall Algorithm. Okay, so assume that we have a graph G here. You see on the board that we have a graph G with 4 nodes, and the goal is to find that and to see that if there is a path from any node in the graph to all other nodes that we have in the graph. So here on the right side of the board, you see we have the adjacency matrix of the graph G. For example, the node A doesn't have any direct path to, for example, any other node except B. So as you see here, there's only one path from A to B, okay? And for the others are 0. And also for the B, C, and D, as you see, there are all the paths. So the Warshall algorithm is really simple, okay? It contains 3 nested for loops that you see here, okay? For k equal to 1 to n, for j equal to 1 to n, and from I equal to 1 to n. That n is the number of nodes that you have in the graph. So here we have 4 nodes or 4 vertices, so n is equal to 4. And here we are saying that assume that we are going to find that if there's a path, no matter direct or indirect path from every node or any node to all other nodes. Okay, so we are going to call this matrix T, and T here stands for the transitive closure. So the transitive closure of a matrix of a graph G is a matrix similar to the adjacency matrix that for any item at location I and j says that if there's a path from node I to node j, okay? And no matter if this is a direct or indirect path, so it's going to be 1. And if it's going to be 0 if there is no path from node I to node j, okay? So here is the Warshall algorithm as you see here. So it's consists of 3 for loops, k from I to n, and so we have like n as it says like the number of nodes. So here we have ti, j. It says that if there's a path from node I to node j, and it's going to be its like current value that we have is going to be either 0 or 1, or if there is a path from node I to k, then from k to j. And as you see here, we have an and condition, okay? Because there might be a case that there is a path from I to k, but there is no path from k to j. So that's why we have here an and condition here, okay? And here's between these two, okay, these are in the parentheses, okay? So here we have a parenthesis here, okay? And this is like the or one, okay? Because it might be the case that ti and j is already 1, okay? So if it's already 1 and there is no path from using the node k, okay, we don't like to put the 0 for value of ti and j, okay? So as also you may see that the time complexity of this like the algorithm is from the big O notation of n cubed, okay? It's really easy to see that because there are 3 for loops, there are 3 nested for loops that are, okay, so the number of things are going to be n multiplied by n and multiplied by n, so together it's going to be n cubed, okay? So still not bad, but you know, it's not something that desirable, okay? So next we are gonna see that for this graph that we have, graph G, what's gonna be the transitive closure of this graph G. We're gonna see it together. So now we're gonna see that what if the I is equal to 1, j equal to 3, and k is equal to 2, that so when I is equal to 1, it means that we are looking at node A, j is equal to 3 means node C, and k is equal to 2 means B. So the transitive closure for 1 and 3, it means that from A to C, okay, from A to C is going to be its current value that we have, that is A to C, as you see, is going to be 0 so far, okay, because there's no path, so it's going to be 0. Or, okay, the value that we have for from T Okay, let's use another color. So it's going to be T1 to 2, or and T going from 2 to 3. Okay, so T1 and 2. Okay, at first also we are initializing the transitive closure with agency matrix. Okay, if you look at the agency matrix, T of 1 to 2, that is going from A to B, is 1, so we are putting 1 here. And okay, so I'm gonna like with this and notation here, and from 2 to 3, that is from B, okay, to C, that is also 1. So it's 1 and 1. Okay, so it's 1 and 1. Okay, so the value for transitive of 1 and 3 is going to be 0, or 1 and 1. So together is going to be equal to 1. Okay, so here for A and C, I'm going to put 1 here. Okay, because there is a path from A to C using the node B. So if you look at the also graph, so I'm going to first going to A, okay, and then I can go to C. So on the transitive closure, the value for the A to C is going to be 1. Okay, now later I'm going to like fill this this transitive closure matrix, and I will show you the final result. Okay, now that's the final transitive closure of graph G. Okay, so I'm going to call it matrix T, okay, or the transitive closure of graph G. As you see, there is a path from A to A. Okay, there's a path from A to A, because if you go from A to B and then from B to C, and also you can go back from C to A. Okay, so that's why A to A. This is a path from A to itself. Also from A to B to C, and also from D. For D, you go from A to B and from B also to D. Also for the rest. But there is no path from D to any other node even itself. So